Okay, let's keep going with solving systems with elimination. Again, yesterday we worked on finding those additive inverses or creating those additive inverses and then eliminating. And today we're going to kind of follow back up with some more practice on that to make sure that we're good with all methods. But we're going to really focus in on what do we do when we don't have a 1x or a 1y and we can't just multiply by a single number, but how do we actually find the least common multiples to be able to multiply through. So remember, there's a couple of requirements that need to happen. One, it is so much easier if the things are in standard form, and we're going to create those additive inverses and cross them out and add down and substitute to solve for the second variable. Okay, so let's go ahead and start with these two equations, this system. Okay, so the first thing I want you to notice is I am not lined up. So I'm not in order. My equal signs are not lined up. I've got a problem. So I need to get the second equation to standard form. So that means I need to move the y from the right to the left. So I need to subtract the 6y. So that gives me 3x plus 6y equals 20. So that's my original equation. And I have negative 4x minus 6y equals 20. Oops, I guess it would help if I made this a 10. Let me write the equation right here. Okay, 3x, 6y, and a 10. And if I move my 6y, that's gone. There is my second one. So there's my equation. All right, so if you think back to yesterday, we talked about how we needed to find additive inverses, and additive inverses were the opposites. So I can see that this one has a positive 6y and a negative 6y, so those are my additive inverses. I am going to cross them out, draw a line, and add down. So 3 plus negative 4, that's a negative 1. 10 plus 20 is 30. And I see that very easily x is going to be a negative 30. Okay, substituting in, I'm going to go ahead and go back to my original equation. And I'm going to substitute in a negative 30. So 3 times negative 30 plus 6y, 10. So negative 90. Adding my 90. 6y is going to give me 100. Dividing by 6, I have a fraction. So y can be 100 over 6, which reduces to 50 over 3. And as a decimal, that is 16.7. So my answer is negative 30, comma, negative 16.7. Or I can have my 50 over 3. Either way. All right, let's keep going. And let's take a look at this next one. So this is the second method that we looked at yesterday, which is I don't have additive inverses. I have to make an additive inverses. And what I have are things that are the same. Okay, things that are the same. So 5x plus 2y equals negative 16. X plus 2y equals 8. Well, I see that I have these two y's. They're the same. And I know that I need them to be opposites. So I am going to multiply one line, and I'm going to pick the top one, by a negative 1. That gives me a negative 5x, a negative 2y, and a positive 16. And now this guy's gone. Now I see I have my additive inverses. So there they are. So I want you to go ahead and hit pause and finish this up. Okay, let's see how we did. Negative 4x, 18 and 16 is going to give me 24. X is going to equal a negative 6. Okay, and I think I'm going to use the x plus 2y equals 8 this time. Put in my negative 6. Adding my 6. 2y equals 14. Dividing by 2, y is going to equal 7. So this ordered pair is negative 6, comma 7. Okay, negative 6, comma 7. So again, if we have our additive inverses, like here, here, I can cross them out. I just have to make sure they're in standard form. Cross them out and go. If I have a 1x or a 1y, I can, I'll take that back, not 1x, 1y. If I have the same, I'm going to multiply through by a negative 1 and change those signs on just one line. And then my third type is when I don't have either of those, okay? And that is going to pull us to what's called least common multiples. And this is the lowest common most multiple that both factors have in common. So we've kind of worked on this a little bit when we were clearing fractions and equations. So we're really looking at when you count by twos and when you count by threes, what number do you see that's the smallest that they have in common? So in this case, if I count by twos, 2, 4, 6, 8, 3, 6, 9, I see they have a 6 in common. If I count by fives, 5, 10, 15, 20, and I count 15, 30, I see that they have 15 in common. Now, I could keep going, and I see they also have 30 in common. So I could use either one, but keep in mind, the bigger number you use, the bigger numbers that are in your problem. So smaller is always better. And 2 and 5, I know that's going to be 10. But worst case scenario, if I can't think of one, I can always just multiply those. Okay, I can always just multiply, and that will work just fine. So that would give me a 10. Okay, so let's take a look at what we have here. So I want you to think about numbers and think about the relationship between 6 and 8. Can I make a 6 and 8? That's the first thing you need to think about. Can I make the smaller number the bigger number? Can I make a 6 and 8? No, I can't make a 6 and 8. That doesn't work. Well, can you make a 5 a 10? Absolutely. And I have a negative 10. So what I need is a positive 10. So if I have a 5y, how do I know what to multiply by? Well, it's going to be division. So you're going to take 10y and you're going to divide by 5. So what is 10 divided by 5? Well, that's 2. So that tells me I need to multiply by 2. So 2 times 6 is 12. 2 times 5 is 10. And 2 times 2 is 4. I'm going to go ahead and rewrite this top one so that I don't have quite as much of a mess. And I'm working inside this box now. So go ahead and hit pause, cross out your additive inverses, and solve. Okay, so I crossed out my 10s because I know they're opposite, and I have a 4x, and I have 24 and 4, that's 28. X is going to equal 7. So I'm halfway there. Now I can use any of those equations to be able to come up with my y value, but I think I want to use the second one, the 6x plus 5y equals 2, because it doesn't have any negatives. So I'm going to put in the 7. I'm going to substitute the 7. So 42, my 5y, the 2, minus my 42. So 5y equals negative 40. Divide by 5, I come up with y equals negative 8. So as an ordered pair, remember this is x and y. I have 7 and I have negative 8. All right, we got 2 left. And one of them we're going to have to multiply both lines. And the second one we're going to have to do extra work because it's not in standard form. Okay, so let's take a look at the first one. And let's think about what numbers, can I make the numbers the same? So can I make a 3 a 4? No, can't make a 3 a 4. Can I make a 2 a 3? Yeah, I can't do that either. So at this point, since I can't do either one, I can actually decide, do I want to get rid of x's or do I want to get rid of y's? It doesn't matter. So let's say this time I want to get rid of y's. So I have a 2 and I have a 3. Well, I know that if I multiply 2 times 3, that gives me 6. And 6 would be the least common multiple. Of my two numbers. So I need to multiply the top one to make a positive 6y. So 2 times what is positive 6? Well, that would be a 3. So 12x, a 6y, and 3 times 8 gives me 24. So I've got my first one. Okay, so if I've got a positive 6y, the opposite would be negative 6y. So this one I have to actually pay attention to signs. Okay, so if I have a positive 3 and I need a negative 6, if I divide negative 6 divided by 3, that tells me that's a negative 2. So I got to multiply by negative 2 this time. So negative 6x, a negative 6y, and a negative 18. So now I actually have my additive inverses. So go ahead and hit pause and solve for x and y. All right, let's see how we did. Crossed out my 6y's. I have a positive 6x and I have a 6, so x is going to equal 1. And I'm going to go ahead and go back to the top two original equations, and I'm going to use the bottom one. So 3x plus 3y equals 9. Put in my 1. So 3 plus 3y equals 9. 3y equals 6, and y is going to equal 2. So my solution is 1, 2. All right, now this next one, it really has some issues because it is absolutely not in standard form. So we need to get it to standard form. So remember, standard form is ax plus by equals c. So if I look at the first one, I see the x and the y are in the right spot, but the 3 is not. So I would have to subtract the 3 on both sides, and that would give me 2x, and I'm going to go ahead and write a 1 in there just so that I don't forget that that's a 1, and negative 3. Okay, now this next one, I kind of need to do a little manipulation, and I think the easiest thing to do would be to move my 7, my negative 7 to the other side, and it would make it positive, and that might make my life a little bit easier. Okay, so we're going to move that 7y. So if I solve that, move that 7y, I come up with negative 3 equals 10x plus 7y. And we know that we can just flip-flop those so that they're in standard form, because a equals b equals a, that's not a problem. We just need to not lose any signs. Okay, so now I'm here. Okay, so that is easier. So go ahead and hit pause and see if you can figure out what you're going to multiply by to be able to get x and y. And there's 2 ways to solve this one. It's kind of up to you. All right, so I think I see a couple things here. I see that I could make a 2 a 10 by multiplying by a negative 5. I also see that I already have a negative 1 here, and that actually is a little bit easier. So I think I'm going to multiply by a 7 to make the opposite of the 7y. And again, it doesn't make any difference if you decide to get rid of the x's or the y's. You just have to multiply to create that additive inverses. So 7 times 2, that's my 14. 7 times negative 1, that's a negative 7. And 7 times negative 3 is negative 21. So now I'm looking at these two problems. And again, my additive inverses are the y's. They're going to go away. So I have 24x is equal to negative 24. X equals negative 1. And you've noticed that these, when I'm solving, it's a one-step equation. It's always just division to be able to get that answer. So that's pretty easy. Okay, so I'm going to go ahead and come up here to this blue problem. So 3 plus 2x minus, I'm going to throw in my negative 1 for the y, equals 0. And this one's going to take a little bit more work to be able to solve it, but that's okay. So 2x, I have 3. I'm going to change that color if I'm going to write over there. I have 3 plus 2x plus 1 equals 0. So 3 and 1 are 4. So 2x plus 4 equals 0. Well, I know I have to move the 4. So 2x equals negative 4. I know x is going to equal a negative 2. So there is the rest of my answer. So I have negative 1 and I have a negative 2. And I'm done. Okay, so let's see what you can do with these. That is our third method of solving systems. Reach out to us if you need some help. Again, you have to create those additive inverses. Don't hesitate. You can always Google solving systems with elimination if you need more examples or want to watch some additional videos. There's also some additional videos underneath the help videos in this chapter. So